No, seriously, I'm really excited to be here after like 3 years of not being able to come, 3 years of not kind of dealing with real people, all this like through the Zoom screen. You know what I'm talking about. I'm also a little bit terrified because it's this beautiful audience, this the beautiful scene, and like I haven't practiced for 3 years, so we'll see how it goes. So I want to talk about failures. The obvious question is why. Could you please raise hands if you ran a production service or a system that you can operate it in real life? Okay, excellent. The majority, I would say. So then I can bet money that you discovered very quickly the obvious fact that dealing with failures, with failure conditions, is the most difficult thing to do, the most important thing to do. Because the happy case, when everything works fine, it's easy to encode, it's easy to test, great. But then the remaining like 5% or 2%, maybe 0.1% of functionality, all kind of Byzantine failure cases, all kind of edge cases, those are the difficult part. And there is this old saying that amateurs study tactics, professionals study logistics. And I took the liberty of reframing this quote to say, amateurs focus on algorithms, and professionals focus on failures. And that's why I chose failures as the topic for this presentation. So there's several known patterns, and I'm going to present several of them today. Those that I work quite a bit with. There are others. I don't claim they'll cover everything that's possible under the sun. So the first one is request response pattern, or RPC, remote procedure call. So what is it? We have a client that calls a server or service, it doesn't matter these days, and it gets a response after the request is processed. That's how like HTTP, gRPC works. So let's take the canonical example, saying our service needs to perform operation of transferring money from one account to another. We need like take debit $10 from one account and credits to the other account. And for that, we need to call two services, like one bank and the other bank, so like blue and purple. So our code that received the request will call the blue service to debit, then call the purple one to credit, and everything is fine, no error, it returns success, happy client. By the way, client here, I chose like the mobile device, but actually it can be anything. It can be any kind of computer, it can be server, service. These days, most communications happen between machines, so it can be just a different machine that's making this call. So on the happy path, everything is great, everything is easy. What if one of these calls fail? Like what if we successfully debited it and failed to credit? Well, in the RPC model, if the call fails, we sort of give this problem to the caller. We return an error and say, sorry, something failed, here's details. We may give you actual error codes, error messages, call stacks, but we sort of push it to the client, which is very simple, very easy. So like in code, I took an example from one of the Orleans sources, Orleans system I've been working on for many years, and there's Ruben Bond here who presented about Orleans yesterday. So these two lines are important. We call one account to debit and the other account to credit. And in C# syntax, if the exception is thrown, the wait will throw this exception. We can catch it, just log, and then throw, and that error gets returned to the caller. So we wash our hands, we're done. Because that kind of makes sense intuitively, because the client has the most idea of what it is trying to do. Is this a retriable error, or maybe not retriable? Should it wait? What kind of actions it needs to take? So there is a great deal of simplicity in this case. But there are also downsides, right? Because we made this call and we debited. How do we know? Like, how do we recover from the situation? Can we compensate? Like, what do we do? It's client's problem. It needs to have a different way to figure this out, have some kind of side channel to understand what actually happened, and take actions for that. If Pat Halland was on stage, I wish he could be here. I don't know if everyone knows who Pat Halland is. He's like a very influential technologist, but he's also a man of a lot of talents. For example, he sings really well. So if he was on stage, he could sing the song, or the Imagine that from Lennon. Like imagine if there are transactions. It's easy if you try. No partial falls below us, above us only sky or cloud. You may say I'm a dreamer, but actually I presented into 2018 here at Jay on the Beach a talk on transactions, distributed transactions. And if we had transactions, life would be beautiful, because in this situation where we make a call to one service, debit, then make a call to the other service to credit, and this call fails, the transactional software would make sure that before the error is returned, all partial actions get undone and no effect of this failed transactions is visible. Transactions do exist. They exist in a particular scope. For example, in database, and distributed databases are rediscovering transactions that are adding this functionality. There's some transactional middleware, like the one they presented. But as a general principle, we can say transactions are not there. You cannot have distributed transactions between two services. There is no real protocol that people implement. I mean, there are protocols, but people don't use them. So we have to deal with this situation in the absence of transactions. So with this request response or RPC pattern, the benefit is that it's very simple. And simplicity has a lot of value, because the simpler the code, the less of the problems we have there. The more complex code, the more issues we introduce and we have to deal with. The downsides of this approach is that we're pushing all the complexity to the client and say, hey, it's your business, not our problem. And dealing with partial successes, undoing results, and compensating actions, that's the hard part here. So the second pattern is persistent queues. Who here used the Kafka, SQS, event hubs, RabbitMQ? I'm sure pretty much everybody. So it's interesting that persistent queues were initially introduced as the mechanism for decoupling systems. They help separate two subsystems in space and time, so that the event can be put on the queue before even producer can put event in the queue before consumers even there. But it got immediately used for reliability. So how does it work? Now, our client that makes a call, a request for transferring money, instead of calling the server, it adds a message into the queue. And all it needs to know that it's succeeded in adding message to the queue. It gets an ACK back, and it's done. It's happy. It's done its job. After some time, this message will make it to the front of the queue and will get delivered to the server. It's not important how it can be push and pull, but at the end of the day, the server gets invoked, and then server executes this action that can call one service, calls the other service. And if there is a failure, it's okay, because the message, the important part of the message gets deleted from the queue only when everything succeeded. And so long as there is any failure, like a failure of the call, or maybe the failure of the whole server, that's okay, because the message will stay in the queue. And that kind of has this semantics of implicit retries, because this message will be redelivered to the server. And that's how we make sure that we'll keep trying until we succeed. So it's a beautiful model. It has this very nice property of decoupling subsystems and kind of built-in retry logic. In code, okay, so I was just showing that we deleted from the queue. In code, there is nothing new, right? The server code is the same. There are two lines, and there are two calls that may fail, debit, credit, just like in the RPC case. There's no real difference. It's just invocation happens indirectly through processing of the event from the queue. What are the kind of issues with this system? Well, multiple. So retries are automatic, which is great, but it's also part of the problem. Like imagine the purple service is being overloaded, and the errors we're getting back are throttling errors. Say, hey, back off. A simple retry logic will make things worse. We'll keep retrying, adding more load to the system. So there's no like notion of exponential back off or circuit breaker in the system. So we have to like either put this logic somewhere outside of the queue or have some kind of intelligence. But in general, this pattern doesn't help with that. The queues are actually of two main categories. They're the queues that don't have order, like SQS or Azure queues, where you take a message temporarily from the front of the queue, and you need to confirm that you're done with it for it to be deleted. If you don't do it within the window of time, that message will reappear somewhere else in the queue later, which is great because it doesn't block, like in this example, processing of the green message doesn't block processing of the blue one or the purple after that. But you can imagine that if this green message reappears behind the next green message, we kind of messed up the ordering of the events in the system, which may be fine in some cases, it may be totally wrong in other cases, because the application developer doesn't expect that the messages that were separated by maybe several seconds in time suddenly get executed out of order. And imagine that happens like once in a million requests. Catching these edge cases and figuring out what corrupted the state is not easy. So there are order queues with strict order guarantees like Kafka or Event Hub, Kinesis. You can use those. Then they guarantee that you will move to the next message only after you process the previous one, which creates a different problem. Like if we have issues with processing this green event, that will block the whole queue. And queues are usually shared. Like you don't create like one queue per request. They have a queue, some partition, like the Kafka topic or like Event Hub partitions. We have many requests coming to the same partition, and you're blocking that partition. Until you're done with that message, you cannot process messages behind it. I mean, you can play games, you can read a bunch of them in the memory cache, but at some point you'll have to stop and say, I cannot move forward until this message is processed and removed or acknowledged. And to deal with that, we have to introduce deal queues, dead letter queues. So we say, okay, we failed to process this message 5 times, or maybe we failed to process it for 5 minutes. We'll take it out of the queue, we'll put it somewhere else, and we'll process it later. And the scary part, most of the time it's done by some kind of manual process because we failed to programmatically process message. Some human needs to go and investigate why did we fail to process it. And again, we violated the whole order of events. We took some message out. Who knows what's going to happen if the green one was processed and then one failed and another one got processed later. Notice that the client enqueued the event and finished with that, but client cannot finish by just enqueuing. It needs to track execution, whether it's completed or succeeded or failed. So client needs another channel, a way to receive responses or results of the processing. It can be done in different ways. Like you can have a queue that goes back with responses, and then client needs to somehow subscribe to this queue and then correlate responses with requests. Usually it's done with correlation IDs. So it's all doable. Just need to write more code around it. Another option is to invoke, for example, the webhook and say, okay, this message is processed, here's the acknowledgement to you. So nothing is free there. Another problem for client is that we want to check the status of the processing. If our message is failing, if it's not processed and it's not failed, what's going on? There's no good way to do it. Like especially with the queues that message appears and disappears, reappears, client has no way really to figure out what's going on. And that's bad for the actual kind of management of the system, for quality of it. If we fail to do one of the actions and we succeeded doing the previous one, again, we have this compensation problem. Queues don't help with that. We need some logic for that. So if I summarize, there are 2 benefits of the queuing system, queuing approach, is that the separation of producer and consumer, and the fact that we get this kind of implicit retries. We pay for that by taking a dependency. Like, I'm sure if you ran Kafka clusters, or you try to even like manage Event Hub's partitioning, that's a new dependency. That's additional workload for operational, for like DevOps engineers or whatever organization you have. It's not free. The third approach is workflows. So how does it work? The client sends a message to the server, and now a server, instead of starting executing this request immediately, it creates a document with the intended execution of this request. I mean, a document can be literal like list of steps to execute. It can be some XML form with steps defined in declarative way. It can be state machine that you persist the state. Doesn't matter. The essence is that we record before we start executing what we're going to do. And so we save it in the persistent store, and after that we return an acknowledgement to the client. So we kind of enqueued the request, but enqueued it in a different way, similar to how we did with the queue, but differently. And once this document is created, we can start executing it. So the first step is to debit from the service. So if that call succeeds, we mark, okay, we're done with that one. Then we try the second call. If it fails, we don't mark that it's done. We can retry it. We can have retry policies. We can back off. So eventually, after retries, presumably it will succeed. If the service was down, we credit it. We mark that the step succeeded. And then, for example, we have a last step of notifying the client to say, okay, we're done with the operation, and now we need to reliably notify that through the webhook call that this is done. And after that, workflow is completed. So how to do this? There are obviously systems like the workflow engines that you can use. They all have their downsides and upsides. They have complexity they introduce. What I've seen many people start by writing their own because they think, okay, I need to implement this simple case. Instead of taking Dependency as another huge, massive system that can handle all kinds of business processes, I'll just write a hand roll, some simple state machine, and I'll persist it. And that's a legitimate approach. I remember many years ago when we had a private hackathon event with the Orleans team, like private preview for 7 major enterprise customers. What surprised me, out of those 7, 3 were writing their own workflows, workflow processing systems or workflow-like systems. And that was like the first signal for me that I should not be ignoring workflows as the approach, which I've been doing before, thinking that, oh, it's the brave new world of a cloud. It's all about high throughput, low latency. No, actually, the workflow pattern is very important because any business process is essentially workflow. And so to implement this by hand, you need to do a lot of steps. Like in the Orleans case, what do? We receive request. We need to persist this intent. Then we need to start a persistent timer we call reminders to keep invoking this piece of code, this object, the grain, to say, hey, check if you need to do something. Then it can be like once a minute, can be once a day, like define the timing. And then we start executing steps. And if the step fails, you need to put a timer and say, okay, I want to retry it after a second, or like back off second time after 2 seconds or 4 seconds. Once the step succeeds, I need to unregister timer. If the whole workflow succeeds, I need to unregister reminder. If I need to change, I need to re-register a reminder different times. So there's a lot of complexity, and I couldn't put this code on one slide, obviously. But it's a totally viable approach. And people hand roll, they switch to some prepackaged solution, they go back and forth. I've seen all kinds of cases. So what are the benefits? The main benefits is this robust handling of partial failures. If we succeeded with the first step and failed with the second, we don't retry the first step. We only retry the failed one. We can have 15 steps in our business process. If the first 7 succeeded, we're not going to try to redo them. In the Q case, we would have to do that. The other interesting aspect is business processes are generally like long running. They're not like millisecond. And workflows support this long running operation can run arbitrarily long. Like if you need to wait, the canonical example they use opening a home loan where you go through multiple steps with some human approvals, and that may take days and weeks. Workflow is totally fine. There is this document, and you keep updating steps as new actions happen. It's also easy now, unlike in the other cases, to query what's going on because each request is associated with its own identity, with its own document, and it's easy to make a call and say, what is the state of it? Has it been completed? At what step is it? What are the last failures? When was that? And so you can totally get the full visibility into what's going on in this business process. Now I want to talk about Temporal, which has its own approach. Temporal is a company that was started around technology that was originally built by our co-founders when they worked at Uber. It's called Cadence. It's a workflow engine, at least that's how it was originally positioned, which reminds me of the scene, I don't know if I remember in Pulp Fiction when the Travolta's character is explaining to Samuel Jackson's character, like, you know what's the funniest thing about Europe? Just little differences. And I promise that's the last pop culture reference from me. So temporal approach is workflow as code. There is no XML, no YAML, no JSON, no graphic tools. You just write code. There are two main abstractions for writing code. One is workflow. So like the thing we need, this business process we need to execute, this set of actions. And the other one, activities. These are actual actions that you can use. So in this example, workflow, I hope it's legible. Workflow is transfer, or still example of transferring money from one account to another. And activities are deposit and withdrawal. Notice that this sample is better because it has a reference ID. I don't think it's worked well. Because for retries, we actually want to have an idempotency ID and the reference ID, which previous samples I was showing, they're too simplistic. They don't have that, but you also need, you always need idempotency ID. So there are workflows that are composed of a set of actions, the activities, and some logic in between. And the implementation of workflow can be as simple as this. It's actually two lines. Again, withdraw and deposit. And notice that this is Java code, unlike the previous C#, because there is no C# SDK for Temporal yet, but it's in the works. I made sure that happened. So there's two lines of code, and there is no error handling. Like, what happens? How does it work? I'll show you in a couple of slides. So that code gets registered in the worker process as an implementation workflow and implementation essential library of activities. You start a worker process and you say, hey, here's my classes that you need to be aware of that implement these types. And to start the workflow, to enqueue the workflow, you just call this one line. Start workflow, the type of this transfer, and then the bunch of arguments that it takes. How does it work? So instead of this server, I showed there is like temporal service or cluster. Usually it's a cluster of servers that kind of guarantee availability and performance. And then notice there is the blue boxes of worker processes. Those are the ones where you register implementation, workflow, and activities. So they connect through the temporal SDK to the server with this kind of pipe with long poll requests to get tasks from the system and return responses, results, and commands. And I'll walk you through this. So the client calls Temporal and says start workflow, like on the previous slide. Temporal creates a document and persists it, just like in the previous workflow example, and responds, OK, I started the workflow, succeeded. And what it does next, it sends the first task, the workflow task, to the worker process and say, hey, you need to start the workflow. And that triggers execution of that function with two calls or two activities that I showed you. It starts executing, and it uses the SDK, and behind the scenes, and starts executing, it returns a result, a response to the server, say, hey, workflow is started, and this is the first task I want to execute. The first line of withdrawal is actually returned back to Temporal as a request for this task to be executed. And what Temporal does, it writes it in the document and the history of workflow that there's this first step that needs to be executed. And then it turns around and returns this task, now with activity task, the green one, to the activity worker and say, hey, execute this, which makes the activity worker make a call, this function call to the service, in our example, to withdraw money from the account. Once it succeeds, it returns the result to the server, and as part of that, it returns also the command for the next line, which is to deposit to the second account. So Temporal marks the first step as completed, and that's the second step, or it can be multiple steps because it can return multiple, a single response can return multiple commands. I'm showing a kind of a simplified version of it, and in reality, there is a lot more functionality, like some more logical statements. But you see that this document gets created as code executes. There is no like predefined schema. There is no like XML file say, hey, these steps will be run. It's the code that drives what goes into this document, and the code may evolve and may change, and there's like versioning support. The point of this approach is it's kind of code first. So we get the second command, we execute the second call, and if it fails, it's okay. We will not say it succeeded. If the worker fails, it's also okay, because the worker will restart and the command will be redelivered to it. Temporal may crash as well. Maybe you restart it, maybe you shut it down. It doesn't matter. The moment you restart it and the workers reconnect, they will continue executing this task delivered or sent to them by the server. So the system is resilient to all kinds of failures, and we don't need to write any application code for that. Just click through the process. So when all steps completed, just like in the previous case, the workflow completed, there is the status, and it can be queried, and normal workflow stuff. So what is the difference with the previous, with the workflow case I talk about? It's really about how simple and easy it is to implement and debug application code. Because the application code runs separately from the server in its own worker process, you run them completely under your control. And you can, for example, attach a debugger and put a breakpoint in the workflow code, in activity code, and we'll just stop there. You can inspect execution. It's totally yours. It's not like you deploy some code that somebody runs for you and get an error and you don't know what to do. So it's really about that simplicity. What you pay for that, you get the major dependency, just like with queuing case, but it's much bigger than the queue you use. In all workflow system, we still have this kind of dead letter problem because we may have a request that keeps failing for whatever reason. The difference here is that the request may be failing because of a bug in the code. For example, you cannot deserialize. You're failing to deserialize some data in the request. Well, you can debug it in the worker as it keeps failing, and then realize, oh, hey, this is the bug. Commit a fix, build new version of the worker, deploy it, and then it'll continue executing. Now your request will succeed. You don't need to put it in dead letter queue. You can handle it kind of in place and keep going. You may ask, what is Temporal really? Does it handle request response? The original design was not for that. The original design was for this kind of more longer running workflows, but you can execute a workflow synchronously. You can say, instead of start workflow, you can say execute workflow, and then it will wait and block until it completes. So if your workflow takes, under a second, a few seconds, you can totally do that. But it's never been a main focus. But recently, we've been talking to some customers that are in this sort of hot path, payment processing, order processing, when they need the first few steps to succeed very fast, so they will not be holding user looking at some spinning wheel in their web page or the mobile app. And this is being optimized. So it's not for request response, but it's growing into that space. Is a persistent queue? Kind of, sort of, because you enqueue requests by starting a workflow, but it's not really because there is no full decoupling. To start a workflow, you need a temporal server to be there. And if temporal is down, you cannot enqueue workflow. So it's not really this full decoupling. And so what people do, they put a queue in front if they need to, so they can put requests and pull them from the queue and then start a workflow. And that decouples them from temporal. The workflow engine, obviously it was built as a workflow engine, but it's kind of growing to be more than that. Last week, before I came here, we had a call with an engineer in one of the FANG companies, and it was an interesting discussion because they used the hand-roll workflow engine to manage their infrastructure dependency, and then realized they were spending more and more time maintaining this kind of their own internal implementation. They decided to replace it with something else. They discovered Temporal, tried it, they liked it very much. The problem is that within the same company, they have an open source, full-blown workflow engine. And so there's a lot of confusion. Why using Temporal and not this in-house one? And this engineer, I don't know if Rob will ever watch this presentation, is that, I have to explain to them that yes, Temporal can do workflows, but it also much more than that. And he phrased it very nicely, so I remember. He said it's actually a framework that up-levels building of distributed systems. Yes, it can do workflows, but it can do much more than that. And what attracted me to this company is that there are all these pretty sophisticated and well-funded major companies. They really like bet on Temporal big time, even though it was a small startup, but still a small startup, even though we had raised quite a bit of money recently. But they see this value in this code-first model where they can implement the normal traditional way without using XMLs, YAMLs, or some visual tools. So there must be something there. I thought, oh, I better join this company. There's something very important is being built. To summarize, we'll look at the 4 scenarios. You can say 3.5, let's say 4. Request response, persistent queues, 2 types of workflow systems. At the end of the day, these are just tools in our toolbox. We have to deal with failures because we need to build robust, reliable, available systems that provide good user experience. And there is no one solution that fits all scenarios, of course. Like if there is something simple that doesn't require any kind of complexity or compensation, if a processing request, for example, a sensor IoT, like a temperature sensor reporting errors, reporting temperature, it's okay to lose some of those readings. It's not critical that every one is processed. You don't need a workflow system for that. It's simple RPC where like it succeeds 99.9% of the time. It's great. It's more than enough for this scenario. But if you're transferring money from one account to another, like Coinbase is one of these companies that actually built an SDK for Ruby to use Temporal in-house. So obviously they see value in doing that. So it's a spectrum of solutions from like very simple to very sophisticated. And kind of my takeaway for you is, or my ask for you rather is, let's be professionals. Let's focus on the hard problems. Let's focus on failures and make sure we build robust, available performance systems. Anybody else can do the happy path. And that's all I had for you. Thank you.
So as we're typing along, I'm going to actually let you pick one of the questions here. But then I'm going to put you on the spot. I'm going to ask you a different one.
The first question, how do you see these applications being used in actual application in the industry? Is there some pattern that you observe? Yeah, like I talk about one of the patterns where the people start with the queuing system, and then they implement some kind of workflow-ish thing. And then they start scratching their head, do I want to do that? The Microsoft, before I left for Temporal, my team ran, like among other things, this service that handles game servers for like all popular Xbox games. And like you need to scale it up and down. You need to have more virtual machines like Friday evening. You need fewer of them on Monday early morning. And it was done in Azure. So you allocate this VM. So you call VM scale sets, VMSS, allocate a bunch of things. So it's like API call, and then you wait, right? And then we wait several minutes before it completes. And literally that was implemented in Orleans in this kind of the pattern I described, where you have these reminders, timers, and then you do compensation. You make sure they don't leak. These VMs don't stay up. And then eventually you arrive to something that, okay, I need to formalize that and build some kind of solution or use a solution.
Okay, and then so just a reminder, because I see some people are still typing questions. If you have questions for Sergey, just look at the link on the back of your badge and you can submit questions through there. So one of the other questions that just came in was, you showed a sequential process in your example. Can Temporal also work asynchronously on one set of tasks?
Synchronously on one set of... Oh, you mean like fan out probably. Like, yes. It's a great question. I showed a very simplistic like sequential execution, but actually nothing prevents you from starting like 10 requests, like 10 activities in parallel, and then kind of joining and waiting for them. There are all kinds of like conditional execution supported. Yeah, the answer is yes.
Okay, cool. And then another one here is, which testing approach do you use in order to be sure that your logic in the workflow is correct? And would you use a unit test or integration testing?
Oh, excellent question. So in fact, there is like the testing facility within the SDK where it kind of simulates execution and it helps skipping time, because if you, in your workflow, you say sleep for an hour, you don't want your test to sleep for an hour. So it's kind of like this tool for writing unit tests and testing this like long running workflows by skipping time. There is support for that. I wouldn't say it's perfect. There is still a lot to do there, and like one of the priorities to improve that tooling.
Okay. Then we've got, can you explain the, sorry, let me repeat that. Can you explain the reason why you chose Airbyte instead of Airflow for the workflow management in Temporal.io?
Oh, it's the other way around. They chose us. Airbyte
Oh, okay.
uses Temporal.
All right. So that was an easy one. Sorry, I'm skipping through a few here. So we went through the sequential process. We talked about the testing approach. And then we talked about why Airbyte chose you. In the workflow example, here's another question. In the workflow example, we didn't see any logs. How do you deal with them and monitor the number of failures? So I can repeat that for the audience.
No.
Yeah. Okay.
So how do you monitor execution? So there are kind of two complementary parts. So the SDK that your code runs with, the worker process is compiled against like one of the SDKs, like Java, Go, like we adding .NET, Python, there's TypeScript. So that SDK emits a bunch of metrics, and you can monitor and see like there's like execution, like latency of execution, failures, all of that you can just get for free from the SDK. Then because you run the second part is because you run these workers yourself, you can log whatever you want and use the normal traditional systems for logging and any kind of additional metrics you want. And that's the beauty with that. It's separated from the server and you're in full control.
All right. And handy, I have my lock on. Okay. And the other question we had was, I think, no, we didn't go through this. It says, so you presented the temporal approach to failure, handling along the more traditional approaches. So why do you believe it is fundamentally different?
Oh boy, fundamentally. I mean, at the end of the day, it's just code, right? So like nothing is fundamentally different. This approach helps write code in a happy pathway where like in the traditional approach with workflow, you define some like model, like some DSL. Fundamentally, they're the same, right? So one can be translated, compiled to the other. There's no fundamental difference. It's in this kind of little differences, like in Europe, where that matters, where if I can put a breakpoint and debug my code, I cannot do the same with XML, right? So it's not a fundamental difference. It's more like usability, productivity. Like developers want to be productive and happy. They don't care if it's fundamentally different or like minor differences.
All right, I'm going to take your word on that one. So that's it for questions. But I do have one question that we got back in 2018, which we're still waiting for the answer for. When are you moving to Malaga?
Our younger child is in high school, and that's kind of, it's complicated when you're a teenager.
Okay, well, that was your excuse last time.
But we raised some money, and I'm talking that we need to expand into Europe, and we have this very good place with a lot of high-quality engineers.
Okay, so are you going to talk very nicely about Malaga when you go back to Washington State?
Of course,
yeah,
I always do.
You're going to talk very well about Malaga and Temporal and why they need to set up an office here and in Spain.
We have a secret deal with the mayor of Malaga.
That's right, you do. When you met Paco the other day, right?
Yeah, every year.
Yeah. So what did you and Paco talk about this time? Paco de la Torre is our mayor, everyone, and Sergey and him are like big buddies.
No, honestly, I was so impressed by the guy like the first couple of times that I started raving, and they were making fun of me, saying, "Oh, like you're the biggest fanboy of our mayor." But now, like when we went on the tour on Tuesday, the actual tour guys started raving about how great the mayor is. Like, it's not just me. It's a good place that's run really well. Like this facility, it wasn't here like a few years ago, right? It was just
It was, but we didn't have it available, and I think we were lucky enough that we were able to get it this year. So yeah.
Anyway, thank you, Malaga, and thank you, Jay and the Beach.
Thank you to Sergey Bykov. Can we please give him a big round of applause?